Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. Okay, I hope you've subscribed. If you've not subscribed, I don't know what you're waiting for. Click on the notification bell so that when I upload new videos, you'll be the first person to know. Okay, what do we have here? We have quadratic simultaneous equation, and we're going to be talking about just the overview in this video. I'm going to just introduce the concept, what to expect, how to solve, the types of solution you can get, okay, and what to expect when solving this. Please try as much as possible to review the previous videos, especially on how to solve quadratic equations. It's very important. I talked about 3 methods using the formula method, using the complete the square method, as well as using the third one was factorization. And under factorization, I talked about the common factor, the difference of two squares, trinomial when a is equal to 1, trinomial when a is not equal to 1. I also added a bonus video as well as how do you use the formula method to also factorize, okay? Good. All right, so that was that for that, okay? So we're gonna go straight into it. So when we talk about a quadratic simultaneous equation, these are like two or more equations that share variables that are raised to the power of 2, okay? Because I know some of you are writing, I'm gonna be writing this as well so that you can take note, but I'm gonna just quickly explain, then I'm going to write it down. Is that okay? So what I've just said is not hard, is that for a quadratic simultaneous equation, we're having two or more variables, okay, but they share the same variables, but they are raised to the power of 2, hence the quadratic simultaneous equation. In the previous video, we just did simultaneous equation, then they are just raised to the power of 1, but here they are raised to the power of 2. So I'm going to write it down so it will be easy for you. So when we say quadratic simultaneous equation, okay, there are two or more okay, there are two or more equations that share variables that are raised to power of 2 up to 2. All right. So for example, something like x squared and maybe y squared. So this is our quadratic simultaneous equation. But as usual, in quadratic simultaneous equation, you are solving both of them at the same time. So for example, we could have something like maybe y is equal to x plus 3, and we have y is equal to x squared plus 8x minus 3. Are you seeing it? So in this case, we're having one a quadratic equation and one a linear equation, and we're told to solve it simultaneously, okay? And that one again, we could have something like maybe x squared plus y squared is equal to 29, and you could have something like x plus 7 is equal to y. So you can see in both cases, you will notice that we're having both a quadratic equation and a linear equation. Or you can also have two quadratic together. You can have x squared plus y is equal to 7, and x squared minus 3y is equal to 8, something like that. Now, but one of the key difference between a quadratic simultaneous equation is that we can expect multiple answers, okay? So simultaneous equation, you have multiple answers. But remember, in a quadratic equation, the maximum you could get was 2 solutions. Do you remember? So we have 2 solutions. Either you have 2 distinct roots, you have 2 equal roots, or you have no solution. That's the maximum you can get. But in quadratic simultaneous equation, you can have multiple answers. This is because the way the graphs of the linear and quadratic or other nonlinear functions intersect, because they have the way they intersect, you can get more answers. And also the point of intersection of both graphs. So last video, I've shown you how to draw a linear graph, for instance, y is equal to x plus 3. You can sketch this. I also showed you how to draw a quadratic equation graph, y is equal to x squared plus 8x minus 3. So where both these two graphs, they intersect, okay, that is the solution for the graph, okay? All right, so like I promised as well, I'm going to write down as well because I'm aware that some of you are also writing. So now the one key difference here, okay? So one key difference of quadratic simultaneous, okay? Of the quadratic simultaneous equation. So one key difference of the quadratic simultaneous equations is that, okay, we can expect, okay, the main thing here is that we can expect multiple, okay? The key word here is multiple, various. We can expect multiple answers, okay? So we can expect multiple answers. So this is basically because the way the graphs of the linear and quadratic or other nonlinear function intersect, okay? So this is because of the way the graphs of linear and quadratic or other nonlinear functions, all right, can intersect. All right. And also, one of the things I also stressed was that the points of intersections of these graphs is the solution for the simultaneous equation, okay? So that the points, all right, the points of intersection is the solutions or are the solutions. Okay, so the point of intersections. So that point, okay, the point that both graphs, either it's a linear and a quadratic or two quadratic graphs, are the solutions of the simultaneous equation. Okay, are the solution of the simultaneous equation. So if you look at this, so let's give an example. Let's assume I sketched the graph. So I followed all the 5 points. I know the size, the shape, the x-intercept, the y-intercept, and the vertex. And at the end of the day, I had this graph here. Is it another color? I had this graph here. All right. Then also, I also had another graph, the linear graph. I found the x-intercept, I found the y-intercept, and I also have this graph, the linear graph here. So let's assume that for both of them, this is the quadratic graph and this is the linear graph. So what I'm saying is that this point, let me call this point A, and this point here, point B, this is the solution for this simultaneous equation. All right? So that means I can say point A, okay? So point A, let's assume point A has the coordinates XA and YA. And point B, we have XB and what? YB. So that means point A and point B, XAYA, XBYB are then the solution for this simultaneous equation. Is that okay? Are the two valid solutions for this simultaneous equation. Okay, so if you look at this now, these are the two valid solutions for that. So now this will now bring me to a thought now. So that means, like in this case, we have two solutions. So what are the possible types of solution we can have? So now I'm going to have 8 videos on this, but I just want to give an overview. So when you solve a quadratic simultaneous equation, there are 3 kind of answer you should get. You could get one solution. Okay, so one solution, that means for one solution, it means that the line intersects at one point, okay? The line or just say, if to put it correctly, you can say the line touches the curve. At one point, some textbook will say the line is tangential, okay? The line is tangential to the curve, all right, to the curve. So what we are trying to say is that when you look at it, it'll be something like this, and it is just meeting at just one point here. But one trick you need to keep in mind is that for this kind of questions, I'm going to explain very soon, when you find a discriminant, all right, I've talked about discriminant before. When you find the discriminant, the b squared minus 4ac will be equal to what? 0. So that means the resulting quadratic equation that you will get from these two lines, the b squared minus 4ac will be equal to 0. Now, it's also possible that you could solve and you could get two solutions, okay? You could get two solutions. And what happens with two solutions is that the discriminant for this one is greater than 0. Of the resulting ones, I'm going to talk about that is greater than 0. But for this to have two solutions, that means the line must meet, or there'll be 2 points of intersection. All right. So there'll be 2 points of intersection for this one. So there are 2 points of what? Intersection between either the line and the curve or just the two curves. All right. There are 2 points of intersection. Okay, so if for instance we have something like this, another line, so you can see there's a point here, there's a point here, or you can have a curve here, another curve there, there's a curve point here, there's a point here. Also the same thing, you can have a curve here and another one curve here, they just meet at what? 1 point. So basically what it means is that for the types of solution to be like this, there are 2 points of what? Intersection here. Then the final one is that there could be one solution, there could be two solutions. It's also possible that there could be no solution as well. So that means there's no solution. And when there's no solution, if you check the resulting discriminant, the b squared minus 4ac is going to be less than 0. So that means when it's less than, it means that there is no point of intersection. So that means the lines, all right, do not intersect. So that means for this case, the lines do not what? Intersect. So when you draw it, when you sketch it, you can see you can have this and this, or you have a curve here and another curve here. They don't intersect. So there's no solution for both of them. So these are the types of solution you can get. So the next question you'll be asking is, okay, Terry, then how do we solve this? Now, there are two basic methods of solving this. So the methods of solving, okay, quadratic simultaneous equation. The quadratic simultaneous equation. So you can either start with the first one, you can use the elimination by substitution. Okay, you can use elimination by substitution. All right, so there are several methods, but I'm only going to focus on the elimination by substitution method. All right, and also you can also draw or sketch the graph. All right, so I've talked about sketching before. All right, so you can do that, sketch the graph. So please look at the previous video, all right, so that you can know how to do this. So basically, you sketch the line graph and you now sketch the quadratic graph and see if there will be a point of intersection. And like I said before, that this will only give an estimate. It will not give the actual point unless you plot it. So if you plot this, okay, if you plot it, then you will get the exact value. But if you want to draw or sketch, all right, you want to just sketch the graph, you're not going to get the exact value, but you get an idea of what it is. And in this video, I'm only going to focus on the elimination method, elimination by substitution method. There are several methods, but I'm going to focus on this because I've talked about elimination and substitution in my previous video in linear equation. So it makes more sense for me to keep or stick to that concept as well. All right, so that is that for that. So when we're talking about simultaneous equation, we're talking about quadratic that we have both linear and quadratic or two quadratic equations, and that we're going to solve them together. And the point that both of them meet is what we call the solutions. And there are three types of solution you should be looking out for. You could have one solution when b squared minus 4ac is equal to 0, or you could have two solutions when it's greater than 0 and no solution. And when it's no solution, it means that the line does not intersect. But when it's two solutions, it means that there are 2 points of intersection. And when it's one solution, it means they just intersect at 1 point. All right? Okay, so I'm going to go straight to the next video where I'm going to talk about how do we now solve this. And I'm going to use the elimination by substitution method. Is that okay? All right, so I'm going to see you in the next video. If you have any question, feel free to drop me a message. And if you've not subscribed, I don't know what you're waiting for, do subscribe. So when I post the next video, you'll get a notification and you'll be one of the first people to view it. All right. Thank you very much, and I will see you in the next video where we'll talk about elimination by substitution method.